What is going on, guys? My name is Hussein, and Facebook is moving all their back end and their front end communication mechanisms to the QUIC protocol. This is the article. It's a very detailed. I love it. And the way that Facebook do things is a little bit different than other companies. They take the protocols and they implement their own versions, and they obviously I believe they open source them. I'm not sure, but for these protocols, I know like React is open source, GraphQL is open source, Proxify is open source. Most of the stuff that they build off the protocol is open source. But they like to have control over what they build. They build it from scratch. And QUIC is no difference. So when they decided to implement QUIC, and QUIC, it's an RFC, obviously, guys. So in order to do that, you have to actually implement it. And Google started that implementation a long time ago, and then they deviated for their own sort of infrastructure, and then it became a standard, and the standard is being morphed into Google's implementation. So Google implemented it, and then they re-implemented it, so they form a standard. Facebook did the exact same thing. They are keeping track with the drafts that are being published of the QUIC. QUIC is not finalized. So in this article, they go through what is QUIC, what is HTTP3, and then they go through what they did, where they implemented QUIC, specifically on the backend, specifically on their reverse proxy. They have their own reverse proxy that they built, and that reverse proxy, both on the front end of it, the connection acceptance now is QUIC, and is on the back end is also QUIC, which is something not all reverse proxies do. I don't believe Nginx do QUIC on the back end. I might be wrong, but I have to double check that. This is very, very new and delicate, right? Most applications, when they say support QUIC, they support it as a front end. I mean, hey, you can communicate through me as QUIC, but do they support it also as a client on the back end to the back end servers? That's also another very important concept here. So Facebook is very clear about that. They have both support. And they brought QUIC to the application level, so the Facebook app, the Instagram app, and all of that stuff. So how about we jump into it and then discuss this article, right? I'm going to leave it below for those who want to read it for themselves, but I'm going to discuss it here. And if you're listening to the podcast, there are no graphics or any fancy things like that. So most of our discussions are going to be audible. So, what is QUIC, guys? QUIC is a protocol that is being pushed into a lower level so that it's accessible by all applications. And it was inspired by, I believe, HTTP2. The main goal of QUIC is, how can I send multiple requests using a single connection in parallel, and somehow identify the responses that come back? Those responses belong to which request. This was a problem with HTTP 1.1. We tried to solve it with pipelining. That was a disaster, but we tried to solve it with HTTP 2 on top of TCP. TCP is its own thing. It has, remember, TCP deals with packets. That's it, right? When you send a packet, you acknowledge that packet, and the packets are sequenced, the packets are flow controlled based on the network, so the network can taste how fast it is and send more content versus less content based on the network bandwidth. So there's a lot of stuff going on in TCP. It was not, it put a little bit of restriction on the HTTP protocol when we moved to HTTP 2. And I talked about HTTP 2, guys. Check it out here. So the idea is, how can I send multiple things? So HTTP 2 came up with the idea of streams. And streams are kind of dedicated. It's just nothing but packets. But now the headers on top of the request that I'm sending has clear identification of a stream ID, which is kind of translate roughly one-to-one to a request ID. So I know each request are sent in parallel. Doesn't matter, because if they come back, they are tagged with the stream ID, which which tells me which request this is coming from. It solves a lot of problems, so that's one of them. It also creates a lot of problem because of TCP, right? Because TCP has a head of line blocking problem, so I'm not gonna go through it, but check out my HTTP 2 playlist. Really, I talked about it many times. So HTTP 3 wanted to solve this, but it's like, wait a second, guys, why are we building this on top of TCP? Let's just build it on top of UDP as HTTP 3. But they say, wait a second, what if I don't want to use HTTP 3? I don't want the HTTP protocol. This is good stuff that you guys built. You guys allowed me to send multiple requests, multiplexing. We don't have this problem. We have this problem. Everyone want to solve it, but you're forcing me to use the HTTP protocol, which is to a lot of people, especially the database people, think it's an overhead, right? Because you have all these headers and things that we don't have in my building and protocols. So they decided to actually push this the specification of the beauty thing of HTTP2, which is the streams, into QUIC, into a layer 4 protocol on top of UDP. So UDP is just, just send a request and then that's it, forget about it. There is no acknowledgement, there is no flow control, there's nothing. So we're gonna build this on the application layer. The application happened to be now the network layer. So it's a very, very powerful thing. So now I can technically build a database that uses QUIC, and it's very, very powerful. Especially, guys, think about this. Nobody talks about this stuff. If I have a reverse proxy and or just any application, and that application tries to connect to a database, what do we do today? We do this thing that's called connection pooling. Establish many connections and send multiple SQL on different connection, right? Because we cannot send 2 SQL from 2 users on the same connection at the same time, because we don't, same problem. You don't know which response belongs to which request, right? That's the same exact problem. So QUIC solves this problem. Just have beautiful one connection and then create streams or channels. RabbitMQ figured this out a long time ago, and they created their own idea of QUIC. They called it, I don't believe it's the RabbitMQ, it's the Advanced Message Queue Protocol, AMQP, and has the idea of channels. SSH works exactly the same way. SSH has the idea of channels, which is very similar to stream. I prefer the word channel is because it just makes more sense, because this is a channel, I can send multiple stuff in this channel, and it has nothing to do with the other stuff, yet it's in one TCP connection. But here we don't have TCP, it's just UDP. So that's the idea of QUIC. So that was a summary of QUIC. Obviously this is not, I'm not reading what they're saying, I'm just telling you from my experience what this is. Obviously when we move to QUIC, we get a lot of stuff for free. There is no this thing that's called a handshake, the TCP handshake, which is send ACK, and then ACK, and then there's the TLS, because you need to secure stuff, so that's another round trip in case of TLS 1.3, and 2 round trips in case of TLS 1.2. So all of that stuff just adds latency, right? So when they moved to QUIC, people who built this thing are so smart. They solved all of that stuff. They said, okay, hey, so wait a second, let's make this secure by default. So protocol ossification in case of HTTP2, we talked about that as well. Check it out here. It's no longer a problem. Secure by default. So the first request you send is the SYN, and it is also the establishment of connection, and it is also the Diffie-Hellman parameter keys and my extensions, my TLS extension and everything. So it does everything in one single round trip. And not only that, if the smart engineers are working on this, there is something called zero RTT in QUIC and also in TLS, but it allows you to don't have any round trips. Just immediately, if you have prior knowledge with the server, a prior handshake established, you can renegotiate that and send data immediately in the first request. That is so powerful, guys. That is so powerful, especially when you're moving from one connection to another connection, right? Let's say you're driving out of the garage, and that connection is being dropped Wi-Fi to 4G. I see it today. and people didn't solve this yet, I believe, right? If I move and I'm watching like a live stream or a YouTube video, it disconnects. Why? Because yeah, I think YouTube uses QUIC, but it's not zero RTT, right? Because the moment you move out, you have to renegotiate the connection, and that you feel that disconnect, right? With zero RTT, I believe, I might be wrong there, you won't have that anymore. All right, so that was quick, guys. I don't believe that was quick. I talked a lot about that, but you can skip it. I'm gonna add YouTube chapters if you want to jump into the interesting part. But so what Facebook did is like, okay, QUIC is great. We all agree that QUIC is awesome, right? So how about we actually implement it? So they said, okay, the QUIC implementation. We're not gonna rely on Google's implementation. That's Facebook. They have the resources. They can do whatever they want. So they said, we're going to build our own QUIC implementation, and we're going to call it MVFast. Move fast, I believe that's what it stands for, maybe. And they built, and this is just following their footsteps of always implementing their own implementations. Proxygen for the HTTP library, Zero Protocol, Fez for the TLS library, and their CAFCAN, what was it called? The reverse proxy. It was called something, I forgot. There you go. It's called Catran. That's the reverse proxy, right? So they made their reverse proxy QUIC aware. They made their Proxygen QUIC aware. They built MVFast as a QUIC aware protocol. Okay. So they built it themselves. You might say, Hussein, how can they build something while it's still being developed? QUIC is not finalized, right? Well, they are keeping track of these drafts that's being published. I believe there's around 29 drafts or something like that, and you can actually find out by going to, if you go to google.com, right? And people who's listening, I'm actually opening the dev tools, and hopefully this shows up. There you go. H3Q050. That means it's actually draft 50. Is that right? I might be wrong there. So yeah, Q50, that's the draft number. So it shows you which version of QUIC they're using. Okay. And yeah, so they're keeping track of this, and they implement these features as they go into the RFC. So they built this stuff. So they want to start deploying this stuff. So they deployed it on the back end. So they said, hey, if we want to succeed with QUIC, we need to test it internally between our services, between microservices. I don't know if Facebook actually call it microservices, but internally between a high bandwidth 10 gigabit network internally, right? Between two services, they talk through this stuff. They started implementing QUIC. Because if that didn't work, that's what they said in the article. If that didn't work, we're not gonna deploy it on the client, because there's no way it's gonna work on the internet if it didn't work on a 10 gigabit connection. So they did implement it, and they saw good performance increase. So they said, okay, let's move it to the front end, that's the next step, the Facebook app. So talked about QUIC. We talked about implementing QUIC on the back end, which was successful. They have to do a lot of work. I'm not trying to minimize the work they did. They did a lot of work to make it work, right? And the idea here is that, again, guys, I'm gonna emphasize this again. Implementing QUIC on the back end is not easy, because there is always, in the back end, there is a front end and a back end all the time, because you communicate between a client and a server, and the clients should support QUIC, understand QUIC, which is their MVFast library, I believe, and the server should also understand QUIC. And if the server also acts like a client, which most reverse proxies, layer 7 reverse proxies do, in fact, that client aspect of that server needs to also support QUIC. That's a lot of work. Okay, so the Facebook apps, they said, okay, let's go ahead and implement the Facebook app. They divided the Facebook app into two parts. They have the dynamic content. They also had the static content. The dynamic content, think about if you use Facebook, I don't know who does anymore, but if you use Facebook, you load a Facebook app, and then you get a bunch of comments, right? And each comment has this much likes, and not only that, some of the likes are from your friends. So Facebook actually show you, oh, John Doe liked, and 700 people liked this photo, right? So this kind of metadata, this kind of comment, this is lightweight stuff, and they do it using GraphQL. We talked about GraphQL, check it out right here. But GraphQL in a nutshell, if you don't know, I like to simplify it as this is the ad hoc way of querying a backend on the front end. So you're providing a query language, an ad hoc query language that can be morphed very easily in the front end, instead of hard coding almost, or ossifying your REST API so that it satisfies a single use case, like, hey, give me all the users, or give me the user /7, and when you go user ID number 7, your REST API just gives you everything, right? You might argue that, hey, Hussein, I built REST APIs in my life, and I can pass parameters to ask what comes back. That's absolutely fine, but that's like, you're gonna imagine that's you rewriting what REST API definition means, according to Roy Fieldy. So REST API is great. I talked about the benefits of GraphQL versus REST API. Nothing is perfect. Really depends. GraphQL implementation is tough, and if you don't know what you're doing, you can shoot yourself in the foot. All right. And I have people from the YouTube community here and the channel actually tell me that, hey, we implemented GraphQL, but a lot of people in the front end don't know how to use it. So they will form random queries that kills the database because they were going through path that they have no indexes, or a database execution plan that just kills the database. So you need a little bit more, in my opinion. If you build a GraphQL as a front end, you need to have back end knowledge, right? You can't just randomly implement GraphQL, but that's outside the scope of the video. But GraphQL, dynamic content. So the response that comes back from GraphQL is so small. So they say, okay, let's start with that, because smaller response size with QUIC, something we can handle, right? Because they don't want to deal with large payload. Large payload with QUIC means a lot of work in your CPU to assemble those packets to belong to which request and which stream. Remember, we talked about that, but that's not free, right? QUIC has expense, and people still working on fixing the CPU utilization problem. Facebook seems to figure something out, and I have no idea if they push that knowledge upstream, because I'm pretty sure they did. But as of I think last month, I've listened to a QUIC presentation from the people from Cloudflare, Google. People are still working on this stuff. They're trying to minimize the CPU usage of QUIC, and that's a problem. You might say, Hussein, why do we have CPU problems with it? We had the same problem with HTTP 2, because now with HTTP 1.1, you take the hunk of string that you get, and that's it. You start from here, that's a string manipulation, and you assemble a little bit of packet until you reach, I don't know, a new line, and that's your end of the body. So you can clearly, very simply identify the end and a start of a request in a given HTTP request. However, that also had a problem with HTTP smuggling when it comes to reverse proxies. I'm not going to go through it, but that was simple. Nevertheless, CPUs don't have to do much work to determine what a request is. However, in HTTP2, we had to do more work, because now guess what? If a packet is arrived, you have to look at the packet, deep inspect it, and look for the stream ID header in that packet. And if that just chopped in half, guess what? You have to wait for all of that stuff to assemble to get a useful information of a packet. And I'm not sure if an HTTP2 packet or HTTP QUIC packet fits nicely in a TCP segment or a UDP segment, right? That depends on the MTU and other stuff as well. So CPU need to do a lot of work to kind of assemble the stuff. Oh, your stream 1, go to this channel. Your stream 2, go to this packet. Start just working, and you're building, I don't know, arrays and stuff like that. It's not easy anymore, right? So more work, more CPU usage. So they said, okay, let's start with a small thing, GraphQL. So it started with GraphQL. They said they saw a little bit good stuff. Let me read this article. However, there were regression. What was most puzzling was that despite QUIC was enabled only for dynamic requests, we observed increased error rate for static content downloaded with TCP. They didn't touch static content. They still used TCP and HTTP for for static content. The root cause for that would be a common theme that we run into the transition traffic to QUIC. And that theme is the heuristics that we're going to talk about, I believe. App logic was changing the type and quantity of request of certain type content based on speed of reliability of request. So this is going to be a theme now. You're going to read it and you see TCP is a different protocol than UDP, which is which is QUIC is built on. So if you're building QUIC, you have to build flow control, you have to build acknowledgement, everything that is in TCP, you have to build it at a higher level, a little bit. Still layer 4, but a little bit higher level. It's not something that's taken care of by the operating system, right? That's the application. And when you do that, there's assumptions that have been made for years and years and years when it comes to TCP, right? If I do a flow control TCP, it takes care by the operating system. So, okay, the operating system will say, okay, this is a request, and I send the request. I got the response within 30 milliseconds, so this network is good. So let me send this much request extra. So when we move to this heuristic, these just numbers that have almost hard coded in the app, you move to UDP, and all of a sudden this explodes because things are faster in UDP because there's no acknowledgement, right? At the operating system level. So, oh, I sent a request and I got a response really quick on these packets. So less than 100 million requests. So the app started drastically, unproportionally sending insane amount of bandwidth, thus actually killing the performance. Does that make sense? That's the problem that they faced here. And if someone reading this from Facebook, I would love to read more or see if I said anything wrong. If I missed anything, I'd love to be corrected if I said anything wrong. So they started with dynamic content. They working with dynamic GraphQL queries, and they another part of the app started crashing because the whole thing is just one library, I believe, right? It didn't really differentiate. So they fixed that and they moved to the static content. Now that's the next step. They moved to the static content. That is your images, your videos, things like that, right? And then because now you're dealing with the larger response sizes, right? This is an image. I don't know. It's a big, large image, right? And then it's a video. This is a 4K video or a 1080p video. So that's a lot of response that comes back. So QUIC is gonna spend more CPU usage on this compared to GraphQL, which is like, I don't know, a few hundred kilobytes or maybe less. So that's a problem here. They fixed that. Run the same exact problem with the heuristic thing. So they tweaked their heuristics. Says, okay, relax, app. Don't freak out, right? Don't freak out when you see like a great performance. Don't just send a huge number of requests just because your application is doing great. No, that there is always you cannot go to infinity. There's always a cliff after that. You start dropping performance in every single thing because there's other constraint that pushing you down, whether it's the CPU cores, whether the RAM, other stuff, right? Then they start pushing to all the content, right? So the QUIC for all content. So they moved it to their actual streaming, live streaming. They moved it to the Facebook gaming and all that stuff, and they fixed the same thing, exactly the same. So nothing to talk about here. The same problem. They saw 22% increase. Awesome stuff. But the flow control is the most problem that they faced, and the occurring theme, right? And the P99s and the P90s and P75 saw a little bit increased traffic in my opinion, that's good. This few, if you have the P99s, the request that used to fail like one every, I don't know, 100,000 requests, those are now less, which is awesome. So they push it now to Instagram, and Instagram here, guys, what they wanted to do is like once they push it to Instagram, they didn't have any problem because most of the problems they already solved with the Facebook app. So moving to Instagram was a piece of cake for them, according to what I'm reading, what I read here. Okay, so I don't believe it was a piece of cake, but now, guys, if you're using Facebook, if you're using Instagram, because Instagram belongs to Facebook, iOS, Android, you're all running QUIC, and you don't even know it. What they didn't mention though here is, what if I'm behind a firewall that blocks QUIC? They didn't mention anything of that. Because, let me rephrase that. What if I'm behind a firewall that blocks UDP? Because UDP was abused, right? Because it's an open channel that you can just send without me needing to know you, right? So a lot of protocol blocks UDP, right? If it's not a DNS request, especially, right? So I don't know what they did with that. Right? Do they reverse back to CDP? I know that HTTP 3 does that. Okay, but they didn't mention that. And obviously there are the TLS over DNS, they're securing their DNS queries. Now they are also securing their DNS queries. Again, they didn't mention which provider they use for their DNS server. Does Facebook, guys, if anybody know, does Facebook use their own DNS provider? Right, because I'd like to know. Because if they don't, if they do, then everything in Facebook is secure. That tells me that even if a government wanted to block Facebook, they can't, because they can remove the Facebook app from their app store, like with a court order maybe. But if I downloaded the Facebook app, right, and an Android using the unknown sources, whatever that thing is, right, APK, the first query I'm gonna make is, what's the IP address of Facebook? And that's encrypted with DOH or DOT. Now, apparently from this article, I didn't know that. Now, guess what? If it's that encrypted, there's no way other than the SNI, server name indication, which doesn't exist in QUIC, right? It's always ESNI, I believe, in QUIC. So there's no way for the firewalls in the middle or the government or the ISP to actually detect where you're going. So they cannot even block that. That's why China blocks TLS 1.3 and ESNI. China, Russia, I believe they're blocking it right now. I don't know if that order got into place, but they're blocking because they're blind with these technologies. They are blind, and QUIC, definitely they're gonna block QUIC. Definitely, no news about that. Just because I think Facebook is blocked in China, isn't it? Right? I'll be surprised. I don't know if Facebook is blocked in China. I believe it is. Now I'm gonna know. I want to know how it's blocked. I'm interested to know how it's blocked, because are they harkering all the IP addresses of China, of the Facebook app? because now with this, I'll be surprised how the heck does the Great Firewall of China blocks Facebook? Because it's behind DOH, behind all that stuff. It's QUIC. Maybe China will say, hey, F QUIC, we'll just block everything. All right, guys, that's the whole article. I really enjoyed reading it. I'm going to leave it below for you to read it. I'm going to give props to Matt Joras and Yang Chi for writing this amazing article. I'm gonna post this video in a few minutes and get back to work. Love you. Stay awesome. Subscribe for more of these deep inspection of what people in the software engineering community is doing. That's what I do in this channel. I discuss backend engineering specifically. That's what I like to discuss, at least in this channel. So if you like this stuff, subscribe, hit that like button, and share it with a friend. And you can also listen to this on the podcast on HusseinNasser.com/podcast, or just search backend engineering. So just search my name on your favorite podcast player. Should pop up there. Appreciate you. Thank you so much, guys. I'm gonna see you in the next one. You guys stay awesome. Goodbye.